and wants us to do the same. Why do you think it sucks? What's the problem?
Well, that statement has been widely misinterpreted. But the point I was making is the point that we both made, which is that why is it that a teenager can learn to drive a car in 20 hours of practice, a 10-year-old can clean up the dinner table and fill up the dishwasher the first time you ask the child to do it. Whether the 10-year-old would want to do it is a different story, but certainly can. We don't have robots that are anywhere near this, and we don't have robots that are even anywhere near the physical understanding of reality of a cat or a dog. And so in that sense, machine learning sucks. It doesn't mean that the deep learning method, the backpropagation algorithm, the neural nets suck.
That was obviously excellent. Yes.
Obviously, that's
yes.
great.
Yeah.
And we don't have any alternative to this. And I certainly believe that neural nets and deep learning and backpropagation will be, are with us for a long time, will be the basis of future AI systems. But how is it that young humans can learn how the world works in the first few months of life? It takes 9 months for human babies to learn intuitive physics like gravity, inertia, and things like this. Baby animals learn this much faster. They have smaller brains, so it's easier for them to learn. They don't learn to the same level, but they do learn faster. And so, it's this type of learning that we need to reproduce. And we'll do this with backprop, with neural net, with deep learning. It's just that we're missing a concept, an architecture. So I've been making proposals for the type of architectures that could possibly learn this kind of stuff. Why is it that LLMs handle language so easily? It's because, as Adam described, you train an LLM to predict the next word or the next token, doesn't matter. There's only a finite number of words in the dictionary, so you can never actually predict exactly which word comes after a sequence, but you can train a system to produce essentially what amounts to a score for every possible words in the dictionary, or a probability distribution over every possible words. So essentially what an LLM does is that it produces a long list of numbers between 0 and 1 that sum to 1, which for each word in the dictionary says, this is the likelihood that this word appears right now. You can represent the uncertainty in the prediction this way. Now, try to translate it, the same principle. Instead of training a system to predict the next word, feed it with a video and ask it to predict what happened next in the video. And this doesn't work. I've been trying to do this for 20 years. And it really doesn't work if you try to predict at the pixel level. And it's because the real world is messy. There's a lot of things that may happen, plausible things that may happen. And you can't really represent a distribution over all possible things that may happen in the future, because it's basically an infinite list of possibilities, and we don't know how to represent this efficiently. And so those techniques that work really well for text or for sequences of symbols do not work for real-world sensory data. They just don't. They absolutely don't. And so we need to invent new techniques. So one of the things I've been proposing in one in which the system learns an abstract representation of what it observes, and it makes prediction in that abstract representation space. And this is really the way humans and animals function. We find abstractions that allow us to make predictions while ignoring all the details we cannot predict.
So